Hi, everybody. My name is Mike. If I actually tell you what my last name is, you won't be able to pronounce it, so just call me Housekeys. It comes close enough. So a little bit about me. I've done like 2 talks before here at Polyhack. This is my 3rd one. And I generally pick topics I know nothing about, learn about them, and then share. So that's kind of what I'm doing right now. So we're going to be talking about blockchains, but in particular, we're going to be talking about private blockchains. Everybody is aware of cryptocurrency. That is something that we will not be talking about today, but instead what we will be focusing on is blockchain technology. In particular, something which is called private blockchains. So first, quick blockchain primer, and by quick I mean really quick. So traditionally, they're decentralized. So that basically means that there is no central authority which controls access to writing to the blockchain or reading from the blockchain or whatnot. The reason why is because the idea it was supposed to be that everybody can sort of have a transparent ledger of transactions that they can look at. So that's why I'm saying traditionally, because right now with private blockchains is a little different. Theoretically, they're immutable. So why theoretically? Well, in the vast majority of cases, when a transaction is written onto the blockchain, you are not allowed to change it. It will be there forever, simply because of the nature of the data of the way that the data is stored on the blockchain, where you have one hash, which kind of refers to all the previous hashes in all the previous transactions, all the previous blocks. So basically, if you modify something before your current transaction, it will not be accepted by the system. Now, I'm saying that this is theoretically immutable because if you happen to control 51% or more of the machines on which the blockchain is distributed, then you can sort of dictate what goes onto the blockchain, what doesn't. In some cases, I believe there was a paper somewhere saying that if you control only 33% of the computers which contain the distributed ledgers, then you can actually sort of dictate what you can and cannot have on the blockchain. But these are things that are mostly for bad people to do. And finally, they're distributed. So basically, there is multiple locations of the ledger sort of floating around across multiple machines, and the idea is that there is something which is called a consensus algorithm, which says, okay, you know what? We all agree that this is the blockchain and the transaction ledger that is the source of truth, and we all agree that that's what it is, right? So there's a whole bunch of algorithms that explain that as well. Now, what are public blockchains versus private blockchain? I actually said multi-chain here, and I don't know why my computer is doing this, but I said multi-chain here because later towards the end, we're going to be doing a quick demo where we're going to be creating a blockchain across 2 different nodes on 2 computers on 2 servers that I have somewhere in the world. So let's take a look at the main difference between public blockchain and private blockchain. Well, the main difference is that public blockchains do not restrict read and write access to the actual ledger. So if you actually want to write something to it, you can do that, provided that it is done within the confines of some rules of the type of blockchain that you're utilizing. The private blockchain, on the other hand, controls specifically who is allowed to read, who is allowed to write, and who actually can belong to the particular network of machines on which all these distributed ledgers are found on. So that is the main key difference. Now, there is some granular points. So blockchain's activity is visible only to chosen participants, not to everybody. So this kind of demises the whole concept of, open blockchain technology because this is something that only if you're part of the network and if you're a participant of that network, you can only view those transactions. Then it controls which transactions are permitted, and permissions are actually propagated as metadata within a particular block. So once again, there is a central authority which determines and controls which transactions are allowed, which ones aren't. And finally, you kind of enable mining without the proof of work and associated costs. So technically what happens is that the cryptocurrency aspect of it becomes a moot point. You don't really need to have it. It's not required. For whatever reason, if you want to have that kind of aspect, then Multichain allows you to do that. In fact, Multichain is based on the Bitcoin architecture, which, by the way, means that it does not support, it does not actually support at the moment contracts, right? Exactly. See, I'm still learning. It does not actually support those, basically the contracts. So now we're going to move on to the next slide. Now, what about mining and block creation? So what we're really interested in, like when we're generating cryptocurrency, what really happens is that the miners, which are those, let's say, servers or groups of servers that tend to solve difficult mathematical problems, when they solve one of those problems, then they are being rewarded with a cryptocurrency or a bit of cryptocurrency or something, right? Now, because these, because this is kind of a moot point in private blockchains, the only thing we're really concerned about is to make sure that not one single miner hogs the ability to basically generate these blocks. So, I mean, this presentation is going to be available, but without going into too much detail, what happens is that there is something which Multichain keeps in mind, which is called mining diversity, which basically guarantees that not one single block will actually hog the whole process of creating, of mining. And basically, it's all dependent on a round-robin scheme. That's essentially what happens. We're going to go to the next one. Now, private blockchains versus distributed databases. So what is the main difference? Well, first of all, if we actually think about distributed databases, they're usually, yes, you can have replication and whatnot, right? But usually there is a central location where the data sits. If you're a bank, then that data and those servers sit behind copious amounts of firewalls with individuals that are strictly vetted to control whether access is granted or not to those people to perform certain actions. With private blockchains, that actually, because it's taking sort of advantage of the blockchain architecture, the distributed ledger, which is the transaction list, is not really located on one server, one group of servers. Is actually located across, it's actually located across all the servers that are allowed to be part of the network. So let's take a look. So the very first point, participants retain control of their assets via their private key. Number two, like I explained, because of the nature of distributed blockchains and block hashes, no single individual or group can actually modify the data unless it is agreed on collectively. So that like if we're looking at banks, for example, the vast majority of break-ins in the banks where things get stolen, let's say, or transactions get, invalid transactions get applied, is all because of an internal individual, a malicious individual that has gained access to something that they shouldn't have. Or it's a malicious individual that had access to something and then they turned malicious and then they decided to do whatever evil they decided to do. With private blockchains, because there needs to be a consensus across which transaction is valid or not, and those transaction ledgers are distributed across a whole bunch of servers, that sort of becomes impossible for one individual to meddle into the transactions, because the rest of the servers have to agree on that. Also the third point is superior robustness, because if a server disappears, we don't really care. Eventually, once the server will be brought back up, there's going to be an algorithm which is going to sort of say, okay, this is the most up-to-date ledger. Therefore, this is what you need to actually abide by, and this is what you must have. So now, after having this, me talking, I have a little demo for you guys. So what we're going to do is we're going to simulate asset settlement transactions, pretending we're two banks which have their transactions stored on a blockchain. So the idea for this particular private blockchain, an application of, for example, could be speeding up the process of banking settlement transactions between multiple banks. So we all know that banks don't need to be transparent in general with their transactions. Therefore, they will be using a private blockchain to simply speed up the money transfer process between them. So let's see if we can actually play a little bit, and I'm going to show you on the screen. You're going to see a bunch of hopefully cool things. Can you guys still hear me? Okay. So I'm going to be logging into two of my servers. This is one of them. And this is going to be the other one.
You want your human mic?
Yes. Thanks, Zach. All right, so, wow, I never had this before.
We don't have a mic stand quite yet here.
Yeah, and apparently what I'm wearing doesn't work. Okay, so the very first thing we're going to do, I need to read a little bit. So what we're going to do is we're going to create a blockchain for something which we're going to be calling MP Bank, which is Mike's private bank. So here it is. So what we have done is we have actually created it already. What we can do is we can take a look at what kind of parameters this particular blockchain, private blockchain, comes with. So we can do this. There's a bit of a lag. Okay, so this is basically a whole bunch of parameters that can be set that this particular blockchain comes with, right? So when I am going to be creating the Genesis block, I am essentially going to be giving myself admin rights. And then I can change any of these global permissions, such as can anyone connect to it? In this case, it's false. Can anyone send? In this case, it's false. I can also grant it to individual wallets. So there can only be transactions between myself and, for example, another entity on another valid entity. So what we're going to do, we're going to start the daemon right now. And we now have the actual node, which is the Genesis node, which has actually been which has been created. Now what I need to do is I need to go to my AWS server simply because it opened up on a port that I can't control at the moment. So I just need to sort of add this port here. So 7424 is the port I'm adding. Oops. Okay, so now what I'm going to do is I'm going to go onto the next server, which I have here. And we're going to see if we can actually connect to that particular blockchain that I've created on the other server. It's at port 7424. And it should actually give us essentially permission denied, right? Like it doesn't let us do it, but there is one quick thing that I need to change. 7424, give me a sec. 54, 208, 147, 240. That's not quite the error message I was expecting. No, it's not that. It has to do with my AWS here. I just have to enable that port, and sometimes the connection drops here. So, see, there you go. That's what it is. Yeah, the internet here is a little, let's see, MP Bank, that's fine. Why don't I see this? Okay, fine. 0.0.0.0. Custom TCP, 7424. Yes, good old AWS. Why isn't it? Sometimes technical difficulties are inevitable. Give me 1 second.
It's just not at the bottom of the list. It's in the middle of the list.
Oh, I see it. Okay, let's do this. Let's try it again.
It's in the middle of the list.
I know it is in the middle of the list, but for some reason it's not connecting the way it should be. And I promise I did test it and it did work. Let's try it again. Zach, you said, oh, the drama.
Mike,
Yes.
are you sure it's not, it says local only? Maybe you're listening for local connections only.
No, it's not this. Like I know I've tried it with this, so. I mean, I can try it with this and see what happens. Oh, wait. You're right. There you go. But then I have to change this as well. Yeah, okay, that's what you meant. Okay, got it. Okay, hold on. So I think we know this now. 7, 4, 2, 5, 6. There you go. Okay, so we fixed that. Thanks, Sam. So that was a sweat. Okay, so basically we have this second node here. It's attempting to connect. It can't connect. The reason why it can't connect is because we have not granted this particular node the ability to connect. So now we're going to do that. We're going to go back onto our node 1. We're going to go into the command line interface. And now we're going to be adding this particular permission. So we're granting this particular wallet the ability to connect. So now this has been granted. And now we're going to retry this again. And we're now connected to the first node, to the original node. So now what we can do is we can start doing some fancy things, including transferring of, let's say, funds. So let's say we are, actually hold on a second, one quick thing I need to do. I need to actually start the, daemon here. Okay, and now we can actually get into it. Once again, we're going to go into it, into the interactive mode. And here we are. So now we can actually see what our permissions are in this one. There is really no permissions that have been granted yet, other than the ability to connect. But if we go into our main blockchain node, then we're going to see that. That we have a whole bunch of permissions here. So what we're going to do now is we're going to see if we can issue, we're going to see if we can actually, well, first of all, what we need to do is we need to load up our account, right? So we're going to load up the account on the original node. So this is our wallet. And we're going to say that we're issuing Mike dollars. And we're saying that we're going to issue 1,000 of them in blocks of 100. Oh, wait. Let's see here. So, well, let us actually try this one. I think I've actually put in the wrong wallet in there. There you go, this one worked. So now we actually have $1,000, well, 1,000 Mike dollars in our main node. And now what we're going to do is we're going to be issuing 100 to the other guy. So we're going to issue. Actually, let's list assets first. So there you go. We now have essentially $1,000 in 100 units. If we list assets here, we're going to see we also have them, but we actually don't have them yet in the wallet. I mean, these guys here knows that it's on the other one. So what we're going to do is we're going to say the following. Send asset. And then we're going to send asset to this node here. Which is this wallet. And we're going to send M dollars. And we're going to send 100 of them. But we actually can do that because the address doesn't have a receive permission. So once again, we have to grant it from this particular node. So this is what we're going to do. And we're going to say that we're going to receive it. Now it's actually granted. So now we can try to send it. We resend it again. It actually confirmed that it sent it. And now what we can do is we can actually take a look at the balances. So let's take a look at this balance here. Oh. As you can see, there's $900 here. If we go to our other node, we see that now we have $100 on this particular node. Now, what we can do is we can find out all kind of wallet transactions. So let's take a look at this. So this one here basically gives us detail of the particular transaction for this particular wallet on this node. We have received 100 of whatever assets have been defined, and the assets have been defined in this case as Mike dollars. And we can take a look at the same thing here. Where we have indicated that we have sent them to this particular node here. So this is basically it. That's all the demo that I have. Sorry for those technical difficulties. I'm learning it myself as I go. But this is pretty much an example of the kind of assets that you can transfer between the two nodes using private blockchains. So as you can see in private blockchains, as a real quick summary, the very first thing you do is you got to create a Genesis block on your main node. Then from there you have to assign permissions, who is allowed to connect, who is not allowed to connect, as well as who is allowed to receive transfers, who is allowed to make those kind of transactions, and so on. So any questions? And hopefully I can answer, maybe not. We'll see.
So you do have one main node, and the assumption is that whoever has access to that is not a malicious player?
Okay, so yes. So the question was if there is only one main node, then whoever has access to that essentially is the admin behind that particular behind the whole thing. So the answer to that question is yes. This is why this is kind of a centralized system, right? Because if you're a bank, then you want to control the type of assets that you're actually reconciling across multiple locations, right? In fact, when the first node is actually created, then whoever creates the first node gets total admin rights for everything. You can add additional admins to the system by simply propagating transactions across the nodes, which will contain the admin rights inside the data streams. Another thing that I didn't show you guys here, which is possible to do with the multi-chain, is that you can not only transfer assets, but you can also transfer data streams. And then you can also associate those particular data streams with the actual assets that you're transferring. So you can have an asset as well as a description of the asset itself, as well as other things. So, yes, Sam.
So what software did you use to make your presentation? It looked very nice.
What do you mean?
What did you use to build your presentation?
Oh, I honestly, I have simply installed multi-chain on my nodes.
Oh, and so you built the presentation on Multichain?
Yeah. That's why you can actually have your own private blockchain like this. All you gotta do is you just gotta download multichain from multichain.com and go for it.
No, I meant the actual presentation, the slides.
The slides?
Yeah, it looked really nice.
You know what? So this is not a Turing complete solution, by the way. Thanks, Sam. So according to Sam, the only blockchain technologies that matter are Turing complete. Simply because you can then have smart contracts implemented on them, which this doesn't support yet, but I know that they're working on a version. So it will be eventually Turing complete. What?
What software did you use to build your presentation?
I do not understand your question then.
Did you use Google presentation?
No, I use PowerPoint. Jesus Christ, you make it so complicated. Simon, yes.
The proof of the ledger is the Merkle tree.
I'm sorry, the proof of the ledger is?
The Merkle tree.
Yeah.
And
Actually, it's the Merkle hash. Yeah.
And the you control a private blockchain, who can access and who can do what?
Absolutely.
So
Why do you need miners? Because at the end of the day, even though it is still a private blockchain, and even though it is sort of control, let's say you're creating a network of banks, right? And let's say that these banks are spread across the world, right? Do you honestly want to still have one financial institution controlling what kind of goes on that particular blockchain? You don't. What you want to do is you actually want to make sure that there is some sort of fair way of assigning miners to the in the whole actual system, so that not only one institution controls that. Any other questions? Yes.
So based on that, realistically, what you're saying, so you have 3 banks who want to do this network.
Yeah.
So the way they would do it is they would set it up from the beginning. They start with one main node, then they would have to distribute the same rights
Yeah.
to all of them. And after they're all happy with that, they can start.
Specify what you mean by distributing all rights to them.
So that they all have sort of admin power would be symmetrical between all of them.
Yeah, and that is possible, but once again, it depends on the type of business rules that you're actually implementing and the relationship that you have between the banks, right? Yeah. Yeah.
Make sure
Not one of them has them, possibly all 3, right?
part of like the setup process is that they would all have to go through this phase.
Yes, absolutely.
First it starts it,
Yeah.
distributes the
Yeah,
rights,
yeah, yeah.
once everybody's happy.
Exactly. And you can also, in the future, now, right now, you can only have the super admin distribute these rights, right? So you cannot actually have, so only the entity that created the Genesis block can actually distribute these rights. In the future, you would be able to have admins which have the right to distribute other admin rights within the same private network. But that is still in the process when, for Multichain is being developed, right?
The rights within the whole network are all public within the network. Like everybody can see who the super admin is and what rights they have.
Yes, but I imagine those can be customized as well, right? So you can, because otherwise it wouldn't make sense to basically create one super admin and distribute the privileges of the super admin across all the nodes of all the banks, so that all of them have the same sort of privileges, right? So, any other questions?
I think we'll cut it
All right.
there, yeah.
Okay. Thank you very much.
Cheers.
Yeah.
All right, guys.
Jesus.